So, good morning, students. This is S. Arvind, Assistant Professor, Department of EEE, DBS IT Kavali. So, in the previous sessions, I discussed about introduction to the voltage adjusted converter and basic concept of voltage adjusted converter. And now, in this class, I am going to discuss single phase full wave bridge converter operation. Okay. So, in this class, I am going to discuss the single phase full wave bridge converter operation. Okay. So this is so actually fax controllers will generally utilize three-phase converters. Okay, fax controllers will generally utilize the three-phase converters, but here I am using single-phase full-wave bridge converter. So this also may be used in the some designs. So not in all designs. In some designs we are using this single-phase full-wave bridge converter. So in any case, it is important to first understand the operation of a single-phase bridge converter. So that means if you want to know about the single phase bridge converter operation, so at that time you have to know the importance of this one. Okay, so in any case it is important to first understand the operation of single phase bridge converter and here and operation of a phase leg to further understand the principles of voltage converter. So here I am going to explain two things. First one is the operation of single phase bridge converter and next one is phase leg operation. So actually we have the three phase, but here we are using single phase. So that's why I am taking one phase leg operation to understand the principles of voltage converters. Okay, next. So if you see this diagram, this is a single phase full wave bridge converter operation. So here I am using four valves. Here I am using four valves. So that is a 1 dash, 3 dash, 4 dash, 2 dash. And in the left side of this diagram, I am using the DC supply. And in the right side of this diagram, I am using the AC supply. Okay. So if you observe the diagram, so please see the diagram. So it shows a single phase full wave bridge converter. Okay. So the figure shows a single phase bridge converter consisting of four valves. So if you see this diagram, we are using the four valves. So 1, 2, 3 and 4. So one valve containing one thyristor and each four valves containing one thyristor and one diode. So these two connections are in parallel connection. Okay. So if you observe the one, so the figure shows a single phase. So the figure shows a single phase bridge converter consisting of four valves, that is 1 to 1 dash and 2 4 to 4 dash. So here I am using a DC capacitor. So in the diagram I am using a DC capacitor, this one. On the DC side I am using a DC capacitor. Okay. So this DC capacitor is to provide stiff DC voltage and two AC connection points A and D. So if you observe this diagram, we have A and D points. So this one, so in the AC side. Okay. So here the designated valve numbers represent their sequence of turn on and turn off. So here we are using the 1 to 1 dash to 4 to 4 dash, four valves we are using. So these four valves consisting the numbering, that is 1 dash, 2 dash, 3 dash, 4 dash. Okay, these designated valve numbers represent their sequence of turn on and turn off. Okay, so by using these turn on and turn off sequence, we are going to explain the operation of single phase full wave bridge converter. So here the DC voltage is converted to AC voltage with the appropriate valve turn on and turn off sequence. So here the DC voltage is converted to AC voltage with the appropriate valve turn on and turn off sequence. So here this is the waveform of the single phase full wave bridge converter. So if you observe the diagram, we have the first one, we have the square wave. This is an AC voltage, that is VAB. This is in the AC side, that is the AC voltage. So when we get the plus VD, that is the positive peak voltage plus VD, means when the valves 1 and 2 on, we have the positive peak value, that is plus VD value. So when the 3 and 4 on, that means 3 and 4 valves are on, that means it comes under the negative operation. So that means it gives the negative peak value, that is minus VD, and again 1 and 2 is on, that will give the plus VD value. So here, so if you see this diagram, we have this one. So and after that we have the AC current voltage, sorry, AC current waveform. So it contains the sine wave. Okay, it contains the sine wave. So if you observe this diagram, this is the AC current waveform, that is sine wave. So here we have, if the 1 and 2 valves are on, that means it comes under the negative direction, and when 1 dash and 2 dash on, that means it will give in positive side, and 3 and 4 is on, still is on positive side, and 3 dash and 4 dash is on, it comes under to negative direction, and 1 and 2 is on, that means it comes under the negative direction. This is the AC current waveform. And here we have the time constant, instant of time, that is T1, T2, T3, T4, T5 and so on, T6. For every particular of time instant we are using this one. And we have one DC current waveform, this one ID. Okay, and next we have the valve voltage, that is 1 to 1 dash. So I will explain this one clearly. Okay, so as shown by the first waveform of figure B, that is this one, square wave. Okay, this one, that is AC voltage. Okay, so as shown by the first waveform of figure, so with turn off devices, so here I am using 1 and 2 as turn off devices. So 1 and 2 is turn off devices, but here in this case, this 1 and 2 turn off devices will be turn on. Okay, will be turn on. That means 1 and 2 on. So at that time, voltage VAB becomes plus VD for 1/2 cycle. So not full half cycle. Here the VAB becomes plus VD for 1/2 cycle. So if you observe this diagram, so this one, here the turn off devices 1 and 2 is turned on. So at that time, the voltage VAB on the AC side is producing the plus VD voltage. Okay, plus VD voltage for 1/2 cycle, not for whole cycle, complete cycle. So it contains 1/2 cycle. And next, and with 3 and 4 turned on. Okay, 3 and 4 turned on. In the previous case, 1 and 2 turned on. So in this case, 3 and 4 turned on, and 1 and 2 is in turn off condition. Okay. So if you observe this diagram, so when the 3 and 4 valves are on, so it contains the VAB voltage contains minus VD voltage for half cycle, for 1/2 cycle. Okay, so this one. So with 3 and 4 turn on and devices 1 and 2 turn off, VAB becomes minus VD for the other half cycle. Okay, so this voltage waveform occurs regardless of the phase angle, magnitude and waveform of the AC current flow. Okay, so this voltage waveform occurs regardless of the phase angle, magnitude and waveform of the AC current flow. And next, the AC current is the result of interaction of the converter generated AC voltage with the AC system voltage and impedance. Okay, so this one, AC current voltage, AC current waveform is occurred because of, is the result of interaction of the converter generated AC voltage. So that is this one, AC voltage, first waveform. And next, with the AC system voltage and impedance. Okay, so here the AC current is the result of interaction of the converter generated AC voltage with the AC system voltage and impedance. So this one. So here the AC current is the interaction of the AC voltage. Okay, interaction of the AC voltage which is produced by the VAB, that is the AC side voltage, and with the impedance and magnitude. Okay, this AC current is the interaction of the AC voltage, impedance and AC current. This is the AC system voltage and impedance. Okay, and next we have, so for example here the current flow from the AC system, so that is the second waveform. Okay, so for example here I am taking the second waveform, that is the AC current waveform. Okay, so here the current flow from the AC system So it is a sinusoidal waveform. Okay, if you observe this diagram, this is the sinusoidal waveform. If we second waveform, so this is a sinusoidal waveform. So here in this case, so starting from the instant T1, so starting from the instant T1, it is seen from the circuit and the waveform that. So here I am taking the angle theta. So sinusoidal waveform is IAB, that is the AC side current, AC current, that is IAB, and here I am using the angle theta. So this angle theta is leading with respect to the square wave voltage waveform, that is the first waveform. Okay, with respect to the square wave voltage waveform. So here I am taking the instant T1. So starting from the instant T1, so it is seen from the circuit and waveform that. So here I am taking the from instant T1 to T2. So from instant T1 to T2. So here I am taking the turn off devices 1 and 2 on and 3 and 4 off. So VAB is positive and IAB is negative. Okay, from instant T1 to T2 with turn off devices 1 and 2 on. So in this case, T1 in the instant T1 to T2, the turn off devices 1 and 2 on and 3 and 4 is off. That means VAB is positive and IAB is negative. Okay, so if you see this diagram, you will notice. So here in this case, from instant T1 to T2, okay, from instant T1 to T2, the devices 1 and 2 is on. Okay, 1 and 2 is on and 3 and 4 is off condition. So in this case, the current AC current is in the negative direction and the AC voltage waveform is in the positive direction. So compared to the first waveform. So in the first waveform 1 and 2 is on means the voltage is in the positive direction. Here when the devices 1 and turn off device 1 and 2 is on, so here in this case it is comes under the negative direction, and here we have from instant T2 to T3. Okay, from instant T2 to T3. So at this time the 1 dash and 2 dash is on. Okay, that means 1 and 2 is on and 1 dash and 2 dash is also on. So at this condition, it comes to positive direction. It comes to, that is AC current is in the positive direction, and at the same time 3 and 4 is on. So at the time when the 3 and 4 is on means 1 and 2 is in off condition. Okay, 1 and 2 is in off condition. So 3 and 4 is on. So the AC current is in the positive direction. That is from T3 to T4. So from instant T3 to T4, 3 and 4 is on. From instant T2 to T3, 1 dash and 2 dash is on and the AC current is in the positive direction. And from instant T3 to T4, the turn off devices 3, 4 is on. Okay, 3 and 4 devices is on and the AC current is in the positive direction. And from instant T4 to T5, and from instant T4 to T5, the devices that turn 3 dash and 4 dash is on, but the AC current is in the negative direction. And next, at the instant T5 to T6, 1 and 2 is on and the AC current is in the negative direction. So this is from T1 to T6. Okay, T1 to T6. From T1 to T2 we have one operation, T2 to T3 we have one operation, and T3 to T4 we have one more operation, and T4 to T5 we have one more operation, and T5 to T6 we have one more operation. Like this, the AC current waveform is designed. Okay, that is the second waveform, sinusoidal waveform. Okay, and next we have the DC current waveform. DC current waveform, that is ID. Okay, DC current waveform, that is ID. So here So here the figure B, that is the last button waveform, that is VID, that is the current DC current waveform. So actually that waveform gives the current flow ID in the DC bus. Okay, with the positive side flowing from AC to DC. Okay, so that waveform gives the current flow ID in the DC bus with positive side flowing from AC to DC, that is the rectifier action. Here we have two actions. One is rectifier action and another one is inverter action. So in this case, when the current is flow from positive side, that is flowing from AC to DC, that is the rectifier action. So, and the DC current is a flow in the negative side, that is flowing from DC to AC, that is the inverter action. Okay. So here the DC current ID contains the DC current and the harmonics. Okay. The DC current ID contains the DC current and the harmonics. The DC current must flow into the DC system and for a large DC capacitor. Okay. The DC current must flow into the DC system and for a large DC capacitor virtually all of the harmonic current will flow through the capacitor. Okay, here I am taking a single phase full wave bridge. Here the DC harmonics have an order of 2k. Order of 2k. Here k is an integer. Okay, here k is an integer, that is second, fourth, fifth, sixth. All of the even harmonics. Okay. So if you observe the waveform, that is so this one third waveform. Okay, it is look like a sawtooth waveform. So here when the device 1 and 2 is on, okay, when the device 1 and 2 is on, the DC current flow in the negative direction. When the devices 1 dash and 2 dash is on, 1 dash and 2 dash is on, it comes to the DC current flow in the positive direction. And when the 3 and 4 is on, it again comes to the negative direction. The current flow, the DC current flow in the negative direction. When the 3 dash and 4 dash is on, it again comes to the positive direction. So when the 1 and 2 is on, again it comes to the negative direction. So like this it is fluctuating. So whenever we have the positive direction, that is the flow of current, flow of power from AC to DC and DC to AC, we have the two operations, rectifier operation and inverter operation. We have this waveform, that is the third waveform. And one more waveform is also there in this diagram, that is the valve voltage. So here we have the four valves, that is 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash. We are using the four valves, but here I am taking one wave voltage, that is 1 to 1 dash. Okay, that is the valve voltage. So if you observe, I am taking one diagram, that is the four operating modes in one cycle of a single phase converter. So if you observe this diagram, so first I am taking that the devices. That means only we have the four devices, actually 8. So in that one we have 1, 2, 3, 4. These are the thyristors. 1 dash, 2 dash, 3 dash, 4 dash. These are the diodes. Okay. So here I am taking the devices 1 and 2 on and 3 and 4 is off. So whenever the devices 1 and 2 is on, another two devices is in off condition. Okay. At that time when the 1 and 2 is on and 3 and 4 is off, at that time the VAB, that is the AC side voltage, is positive and current flow is in the negative, and conducting devices is 1 and 2. Conversion is inverter conversion. And again 1 and 2 is on, 3 and 4 is off. VAB is in positive and current flow is also in positive. That is the second waveform. Okay. In the first waveform, the voltage waveform is in the positive when the 1 and 2 is on, and current flow is in the negative. Okay. At that time the connecting devices is 1 and 2. That conversion is known as inverter. And next, again 1 and 2 is on and 3 and 4 is off. At that time VAB is positive and current flow is also positive. But here the conducting devices is 1 dash and 2 dash. In the previous case, connecting devices is 1 and 2 for the first waveform. This is for the second waveform, 1 dash and 2 dash. Okay, here we have the rectifier operation. And next, third one, in this case 1 and 2 is off, 3 and 4 is on. Okay, at that time VAB is negative, that is the AC bus voltage, that is in the negative direction. Current flow is in the positive direction. Here the conducting devices is 3 and 4. Here the conversion operation is inverter. And next 1 and 2 is off, 3 and 4 is on, similar to the previous one. So here the voltage waveform is negative and current flow is in So I am discussing the single phase full wave bridge converter in the last waveform. That is the valve voltage, that is V12 dash. Actually, we are having the 4 valves in the single phase full wave bridge converter operation. But here I am taking one sample, that is a one valve voltage, that is 1 to 1 dash valve I am taking. So here we have the waveform. That is the last waveform. If you see this waveform, you will understand. So here, this is the valve voltage waveform. Okay, that is from 1 to 1 dash. So here when the valve, that is a 1 to 1 dash, here I am taking. So when the device 1 is on, that means we have one waveform, and when the another device, that is 1 dash, is on, we have another another waveform. So this is okay. So here I'm drawing one phasor diagram. So this phasor diagram gives the relationship between AC voltage, that is VAB, and current phasors, that is IAB. Both are AC parameters, that is voltage and current in the AB, that is AC side. So here it is showing the power flow from AC to DC with a lagging power factor. So if you observe this phasor diagram, so this gives the relationship between AC voltage, that is VAB, and current phases, that is IAB. Okay, here in this one, the power flow is from AC to DC with a lagging power factor. So with a lagging power factor. So that's it from today's class. And again, I am taking the class in the next session. Okay.